Hi guys, so today we'll be solving this problem called course schedule 4. Let's read it. There are a total of num courses you have to take labeled from 0 to num courses minus 1. You are given an array prerequisites where prerequisites of I equal to A of I, B of I indicate that you must take courses A of I first if you want to take course B of I. For example, the pair 0, 1 indicate that you have to take course 0 before you can take course 1. Prerequisites can also be indirect if course A is prerequisite of course B and course B is a prerequisite of course C. Then course A is prerequisite of course C, right? So that follows the transitive property. You are also given an array queries where queries of J equal to U of J, V of J. For the jth query, you should answer whether courses U of J is a prerequisite of course V of J or not. Return a Boolean array answer where answer of J is the answer to the jth query, right? So the idea is that we've been given this array of prerequisite where we have values which are stating that the first course, so this one should be taken before 0, right? That is what it's denoting. And the number of courses are actually 2, and we need to return if it's possible to take these courses before these courses, right? So that is the idea here. So whether I can take 0 before 1 if that's possible and 1 before 0 if that's possible, these two things, right? So that is the idea. If this is possible, I don't think so this is possible because the prerequisite says that 1 should be taken before 0. So this will be returned as false and this one be returned as true, right? One quick thing about this problem is that we need to follow the transitive property as well, right? That we cannot, so for example, if you have to take 0 before 1 and then 1 before 2, so which means that 0 needs to be taken before 2. So this one will not be given in the question, but it will be implied, right? So very, like, the approach for this problem is very simple, as all the course schedule problems follow the same topological sorting, right? Approach where topological sorting basically states that any, if there is a directed graph, to arrange nodes such that every directed edge from node U to node V, node U always would come before node V, right? So that is a topological sorting. So U would always come before V, right? And that will give the answer for the sorted nodes in a topological order, right? And we have this famous Kahn's algorithm, which I've talked a lot among my videos, which we'll be using in this problem, where we will have U before V, and that's how we'll use it. And this basically, the idea is that we need to also maintain the transitivity, right? So for that, we know that basically if U is before V and V is before Z, then we also need to maintain U as before Z, right? So we need to store this. So we need to adapt the Kahn's algorithm a bit, where we'll just not keep track of nodes, prerequisites. Like basically we'll need to keep a track of nodes prerequisite instead of just processing the entire tree or graph in topological order, right? So that is the idea. So cool. Let's get to the coding part in order to, like, quickly understand this. It's going to follow the same Kahn's algorithm template, but yeah, let's go ahead. Right. Let's get to the coding part. So first of all, I'll maintain a map, an ordered map, right, which will have the adjacency list, right, that we need to create. So I'm just gonna go and also create a in degrees, as we need to always do in the Kahn's algorithm. So in degree of num courses, and yeah, 0, right? And for auto edge in the requisites, right? And here we will just use the adjacency list and we'll just put the values in it like this, edge of 1, right? And in degree of edge of 1 plus plus, right? So yeah, u needs to be processed before v, and u, because u has a branch, or like, directed branch from u to v. So we are storing the edge 1 in the u as the key for it, right? And in degree of v should be updated because we are going from u to v, right? So that's why edge of 1 should be updated, right? Then I'll just create a queue and I'll push everything which is having 0, 0 degree in degree. Q dot push that I, right? Okay. And from there, I have next step, which is I need to have this unordered map where I'll have unordered set in it, and which will basically store all the dependencies on that particular node so that we follow the transitivity property. So prerequisites, right? From here, I'll just go while q empty, right? And from here, I'll just have this node q dot front, q dot pop, right? For auto adjacent in adjacency list of node, and I'll just have node prerequisite this one, right? And at adjacency place, I'll just insert the node, and as well as all the values which are from the basically in the node prerequisite node, right? I'll just add that as well for the adjacency, right? So it needs to be both ways. So prerequisite in node prerequisites of node and node prerequisite adjacency will have the prerequisite, right? And in degree of adjacency minus minus, that is the idea. And simply we'll just check if in degree of adjacency is equal to 0, then we can just push the adjacency list here, and that would be it, right? So that will give us the topological sorted order, right? And we just need to check if in that prerequisites, if it's possible, like if the queries are right. So 0 before v, right? So 0 before 1. So we need to check if at 0th position, when the key is 0, does that value have 1 in it, right? Because it's a set I've created here. So I'm just going to go through the queries, right? And I'm going to create an answer actually here. Vector bool answer, and answer dot pushback node prerequisites of q1, right, contains q of 0, and I'll just return the answer in the end. That would be it, right? So that is the idea. Let's run this to see if everything is working fine. Yeah, just some typos here. Prerequisites, and yeah, I think here as well. Prerequisites and prerequisites. Okay. Cool. In degree, in degree. That works. Cool. All right. I hope you guys understood the problem. Thank you so much.